This is part 4 of my geometry series, and in this video we're going to be classifying triangles. Just a reminder that tri means 3, and so a triangle has 3 angles. When we classify, what does that really mean? Well, it means we sort or put into groups according to shared or common characteristics. And so I'm classifying these triangles according to their sides, the lengths of their sides. So let's take a look at this equilateral triangle. And this triangle has 3 equal sides. They're all the same length. In fact, I measured it, and they all measure exactly 3.5 centimeters. Now, a little clue. How do I remember that an equilateral has the same length sides? Well, check out the root word of equilateral. Do you see a word there kind of forming? It's equal, right? And so I remember an equilateral is equal in all its sides, the lengths of all its sides. So now let's take a look at scalene. Well, that's different than an equilateral. Look at how many ticks I put into this one. I'm not putting the same number of ticks in each side, these little dashes through here. No, in fact, this one I put 1, I put 2 on this one, and then 3 in this one. They're all different, and that's what a scalene triangle is. The length of every side is different, and no two are the same. Here, all 3 are the same. Here, none of them are the same. And so that's my clue, is how many dashes or lines that we see through each of the signs. So let's take a look now at our isosceles triangle on the bottom. I'm going to put 1 tick through there. How many should I put over here? Is it the same? Should I put 1 or should I put more? Well, it's the same, so I'm just going to put 1. It's the exact same length. Well, what about on the bottom? Should I put more than 1 or just leave it at 1? Well, it's not the same. It's a little bit longer than those 2 sides. And so that's what an isosceles is. 2 sides are the same, and then the other side is different. It's either shorter or longer. Doesn't matter which, but it's just got to be different. And I asked my students, how do I remember? How would you guys remember what an isosceles triangle is? What will your brain do in order to help you remember? And one of my students said, well, she thinks of SOS because this side is my S, this side is my O, this side is my S, and kind of like, help, it's my SOS. And so this repeats, SOS, and that's a good way, I think. I think that's actually a fabulous way to remember what an isosceles triangle is. So I love it. If we take a look at these triangles over on this side, now we're classifying them by their angle measure, not by the length of their sides. So let's take a look at the angles in this right triangle. What do you notice about this guy down here? Well, he is a right angle, so that means that this entire thing, all closed in with 3 sides, is a right triangle. And then the other sides, the other angles, I should say, are acute. And now let's take a look at this acute triangle down here. This is fun. What do you notice about all these angles? If you compare them to this 90-degree angle right here, what would you say? Are they bigger or less? Well, they're all less. They're all smaller than a right angle. And so every angle in this acute triangle is acute. And so they're all cute and little, right? And so that's how I remember him. Well, now let's look at this guy down here. He's obtuse. And look at this angle right here. That is an obtuse angle. It's bigger or larger than 90 degrees. Let me show you where the 90-degree angle would be if it were there. Right here. This is a 90-degree angle, pretty close, right? And so you can see that because of this space over here, that this angle opens up bigger than 90 degrees. And so that is then an obtuse angle. And since there's an obtuse angle in this obtuse triangle, it makes it obtuse. That's how I can classify it. Now you might notice that some of these triangles can be both. If I look at, say, this acute triangle here, look at this side and this side. Does it remind you of one of these triangles over here? This side is the same, this side is the same, this one's shorter. Well, this side is the same, this one is the same, this side's longer. But this one could be also an isosceles. Do you see how they are similar? They share the same, some of the same characteristics. And so this is an acute triangle, but it's also an isosceles triangle. Now look at this right triangle over here. What do you notice about that? Well, the length of this side and the length of this side are the same. Does that remind you of anybody over here? How about an isosceles again? This side then is a little bit longer. So this is a right triangle, but it's also an isosceles triangle. That's pretty cool. So it can be grouped or sorted either way, right? We can call it a right triangle. It's also isosceles. What about this obtuse triangle over here? He's got this big, wide angle over here. Does he remind you of any of these triangles over here? What about this big angle right here? That's a wide, bigger than 90-degree angle, just like this guy. And this guy's short, he's a little bit longer, and then he's really long. Aha, he's short, he's a little bit longer, and then he's even longer. So look at this triangle is both considered to be obtuse, an obtuse triangle, and it's also scalene. So it can also be classified either way. And so you'll find that with our two-dimensional shapes, that we can sort or classify them according to their sides or also according to their angle measures. So that's all I have for now. Thanks for tuning in.